Hey you guys, so I'm just going to go through the notes that will help you get through the moles and grams assignment. Um, just kind of giving you some context and maybe a little bit of practice problems to kind of help you figure out how to do that assignment. So we're going to start by talking about counting atoms by weight. So basically what we're doing is if I were to lay a chunk of coal on the paper right here, we could weigh that and we could figure out how many individual atoms were in that piece of coal, okay? How many individual carbons that is. So, however, because atoms are very, very, very small, it would be a really big number. So if we had just, like a small piece of coal, it would be an insanely large amount of atoms that were in that. So, if we look at the periodic table, we can see that underneath the atoms themselves, there is a number right here. Okay, now that number is called the atomic mass unit. Okay, and what that means is basically because atoms are so incredibly small, it doesn't make much sense to weigh them in like grams and pounds and stuff. So we invented a unit called the AMU, or the atomic mass unit, that helps us talk about how much an atom weighs. Okay, so the AMU is the atomic mass unit, and it is how much an individual atom weighs. Okay, and then conveniently, those are already all on the table. So if we look here, carbon has an AMU of 12.01. That means that if I had a single carbon atom, it would have a mass of 1 AMU. Or if I had a phosphorus, it would have a mass of 30.97 AMU. Okay, so that is the mass of a single atom. And again, we had to invent a new, word. We couldn't use grams, we couldn't use kilograms because they're too incredibly small for that. So let's work some practice problems with that just to get you back into the hang of using the T-chart to solve math problems, which is basically what we're doing in this unit. So if I have a sample with a mass of 1172.49 AMUs. Okay, it's a very, very, very small sample of something because remember, AMU is how much a single atom weighs. Okay, so if I had a sample with a mass of 1172.49 AMUs, we can figure out how many sodiums are in the sample. Okay, so if you remember from, oh boy, it's been a while, beginning of the school year probably, we are going to solve this using a T-chart. Okay, so up here goes the value that you know from the problem. Okay, so I know that I have 1172.49 AMUs. Okay, I was given that in the problem. Now I'm trying to figure out how many sodium atoms are in that sample. So if I look at my periodic table, I can see that one sodium atom equals 14.01 AMUs. Okay, now if I have AMUs here, that means that I have to put AMU diagonally so that those units will cancel each other out. Okay, so if AMU is here, that means that AMU has to go there as well. Okay, now my conversion factor, which is what I have over here, says that 1 sodium equals 14.01 AMUs. So if I have to have AMU down here, I'm going to put my 14.01 down there. And then up here is my 1 sodium atom. Okay, so I'm going to plug that into my calculator. And if you remember, if they're a top and a bottom, you take this divided by that. So I'm going to go 1172.49, and I'm going to divide that by 14.01. And I'm going to hit enter. It's going to give me that crazy long number. Okay, so did I do that right? We're just double checking our lives here. Aw, beans. 14.01 is the mass of a nitrogen. We'll just change that, okay? We're looking for nitrogens now. I don't feel like doing all that over, okay? So, a nitrogen atom weighs 14.01. I'm sorry. Problem still doesn't change, though. So I have 83 point blah, 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 okay? The way that we're going to do these problems, because we have these crazy long numbers, I only want my answer to have 4 digits in it. Okay, so we're going to say that our answer is 83.6, and then I have this 8 right here. I have this 8 right here. I think that the way you guys were taught it was 4 or less, let it rest, 5 or more, let it soar. So if we look at the number next to that, that's a 9. That's more than 5. That's going to round that 8 up to a 9. And then my AMU units canceled each other out. So the only unit I'm left with is my nitrogen. So if I have a sample with this much, or with a mass of that many AMUs, this is how many nitrogens I have. Okay, so let's redo that problem, but actually try and find sodiums instead of nitrogens, because I'm dumb. So we have that sample with 1172.49 AMUs, and I'm looking for how many how many sodiums. Sorry. So in my T-chart, I know that I have 1172.49 AMUs. Okay. And then if we look at the nitrogen or the sodium, good lord, can you guys tell that it's been a while? One sodium has 22.99 AMUs. So I'm going to put that right here. And then that is one sodium. I'll plug that into my calculator. 172.49 divided by 22.9. And that gives me 51. And I don't even have to round that one. Okay. My AMUs canceled, and I'm left with 51 sodiums. Okay, so that's my answer. Cool. All right. So, because this is a very, very, very small unit, okay, AMUs are very small. That's like really small. We would never really weigh something by its AMUs because, like, I mean, I don't even know if we have a scale for that. They did incredible amounts of science to figure out how much an AMU was in the first place. But because that is an incredibly small number, it's really hard to work with it practically, okay? So instead, we are going to be working with a unit called the mole, okay? Get rid of this blank page out of here. So we're going to be working with a unit called the mole, okay? And a mole is basically a made-up quantity, kind of like a dozen. Okay, so if I were to say I have a dozen eggs, you know that I have 6 eggs. Or if I were to say I have half a dozen dogs, you know that I have 6 dogs. Okay, even though the word dozen doesn't really mean anything. We just associate it with meaning 12. Okay, so we have the same thing going on in science and chemistry, where we have the mole. Okay, or sometimes it'll have an E on the end of it. Those are both the same. Okay, but the mole is based off an atom of carbon, but basically what it means for us is 1 mole of something is equal to that mass unit in grams. Okay, so if we look at the periodic table here, I have beryllium. 1 atom of beryllium weighs 9.01 atomic mass units. Also, 1 mole of beryllium weighs 9.01 grams. Okay, let's look at another one. 1 carbon atom weighs 12.06 AMU. But 1 mole of carbon is 12.01 grams. Okay, so it is a lot easier of a way to talk about elements because, like, I know what 12 grams is. That's 12 paper clips. That is enough of a unit. That is enough of carbon for me to, like, hold in my hand, okay, for it to mean something to me. All right, so your assignment today is going to be converting back and forth between moles and grams, and it is super not hard. We're never, and sorry that we had to go through it, but we're never going to really talk about AMUs because they're so small. That was just to get you back into the practice of using your T-charts. So let's say that we have 48.3 grams of helium. And I want to find out how many moles that is. Okay, so how many moles is in 48.3 grams of helium? So I'm going to draw my T-chart. And I've got 48.3 grams of helium. And I always like over-label everything, that way I don't ever get lost. Okay, so if I have grams of helium in the top left here, that means that down here I have to have grams of helium. Okay, now if we look at the periodic table, I can see that helium, 1 mole of helium is 4.00 grams. So 1 mole of helium is 4.00 grams. Again, we're over labeling here so that we can make sure we don't get lost. So then it's just plug it in your calculator. So I've got 48.3 divided by 4 gives me 12.075. And again, I only want 4 numbers, so 12.08, because this 5 makes that one round up. My grams of helium and my grams of helium canceled. So what I'm left with is moles of helium. And again, I was looking for how many moles. I end with moles. Problem's done. Let's do another one. So how many moles are in 57 grams of oxygen? Okay, so I'm going to draw my T-chart. I know that I have 57 grams of oxygen. If I look at my periodic table, I know that 1 mole of oxygen is 16 grams. So if I have grams here, I have to have grams of oxygen down there. 1 mole of oxygen is 16 grams. And it is just 57 divided by 16, which is that big number. 3.563. Again, because that 5 at the end there rounds, and I only want 4 digits. Grams canceled, and I'm left with moles of oxygen. Okay, let me do one more practice problem with you guys before we turn loose. Ooh, this one's a little bit backwards, okay? So, how many grams of neon are in 66 moles of neon? Okay, this is a good one. All right, so I'm going to draw my T-chart. I'm going to put the thing that I know in the top left, which is I have 66 moles of neon. Okay? That means that down here I have to have moles of neon. All right, now if I look at my periodic table, I can see that 1 mole of neon is 20.18 grams. So 1 mole of neon is 20.18 grams. Okay, and then I'm putting that in my calculator. And remember, if they're side by side like that, you multiply. So it is 66 times 20.18, and that gives me 1331.88. But again, I only want 4 digits, so 1332. My moles canceled. All I'm left with is grams of neon. And again, how many grams? That's how many grams. Okay. All right, I'm going to turn y'all loose on your assignment. Hit us up, please, if you have any questions or need any more help. Yeah, but that should get you, hopefully, part of this assignment done. Let us know. Okay, bye.